All right. So we were discussing planes, and so we were asking when a plane is parallel to a line. Like that. So we have a plane, and we have a line L. So how do we know that these are parallel? In particular, they are not intersecting. So we we find about this using vectors again. You know that for a plane we have its normal vector, and for a line we have direction vector. So you see that they must be perpendicular to each other if they are parallel. So to understand if a line is parallel to a plane, we just compute their dot product. If it is 0, then they must be parallel. But there is also a possibility that this line L is contained in N. Anyways, so for example, consider the plane. Consider the plane x plus y equals 1 in space. Let's see that. So let's sketch. X plus y equals 1. Let's sketch. So first, let's sketch the intersection with the xy plane. So x, y, z. So to sketch such things, it would be useful to sketch the intersection with the xy plane. So what is the intersection with the xy plane? It will be the line x plus y equals 1. And first I sketch this line x plus y equals 1 in the plane. So this is 1. This is also 1. These are the intercepts, right? So x plus y equals 1. If I draw this in the xy plane, then it will be this line whose intercepts are at 1. Okay. Then what will happen? So you see in this equation, we do not have z, so z could be anything, which means that, so plane, it goes in all directions. Okay, so this is the plane, x plus y equals 1. So this is the plane that goes above this. However, now let's think more carefully. So you see, this plane will be parallel to this plane. And this will be parallel to the z-axis. Parallel to z-axis. This is z-axis. Why? Because let's check this one. So let's check. So let's first write the normal vector for this plane, x plus y equals 1. What is the normal vector? The components are the numbers in front of x, y, and z, you know. All right. What about the normal vector? direction vector for z. So z-axis is a line, right? So what is the direction vector? What is a direction vector for the z-axis? For example, k vector. K 0, 0, 1. Okay, then let's compute the product. N dot k u equals 0. So this plane x plus y equals 1 is parallel to the z-axis. Really, that it goes parallel to the z-axis. Okay. Then let me ask you the following question. So exercise. So the point is again that to understand if a vector is parallel to a line, we just look at the dot product of the normal vector and the direction vector. If it is 0, then it will be parallel. However, there is this little possibility that if the dot product is 0, there is the possibility that L could be in the plane as well. This is also possible in that case, n dot u equals 0. So this is n. So to understand if this parallel, if this line with this product being 0 is on this line, we need to check if the points of u satisfy the equations of the plane. Anyway, so I suggest you to do the following exercise. So find the symmetric equations, symmetric and parametric equations, equations for the line in space, which is the intersection of this plane with the xy plane. So I suggest you to write parametric equations for this line that you see here. And if we consider this line in the xy plane, then its equation is same, x plus y equals 1, because there is no z. So we put z equals 0 normally to find the equation, normal equation in the plane. However, I'm asking here for the line in space. All right. So this would be a good example for to practice on vector equations for lines. All right. We now move to section 5.7, which is about distance from a point to a plane. From a point to a plane in space. Again, let's draw a picture. So we have a plane like that, and plane P, and we have a point P0 not in the plane. P0 point. And what do we want to do? We want to find the distance between distance from this P0 to this plane. Okay. So first, we should be clear about what we mean by distance from a point to a plane. So we normally know distance from a point to a point, right? So what do we mean by, what can we mean by a distance from a point to a plane? So first of all, if we consider any point, P, any point, then we have a distance between P0 and P, right? And this depends on the point P. Right? If I consider a point here, there is another distance. So now I may consider the following. So I may consider among these distances the one which gives the shortest one. So distance from a point P0 to a plane P, we define it as follows. So first of all, for any point P in the plane, you know we have a distance between P0 and the point P in the plane. And I consider the shortest one. So I call this one the distance from a point to this plane P. This is the definition of distance between a point and a plane. And I want to find this one. So where does this minimum thing occur, right? So at what point in this plane I get this shortest distance, possible distance? Well, if we think a bit, then we get we should get this one at this horizontal, vertical, perpendicular distance, right? In this perpendicular direction. So this direction, let's call this point H, where the line segment from P0 to H is perpendicular to this line segment. Okay, so this occurs, this minimum occurs at P equals H. So it should be equal to the distance between P0 and the point H here. Okay. Where, so let me write, P0H is perpendicular to this plane P. All right, now I want to find this distance. So my shortest distance now is here. So from here to here. Yeah, this will be the distance from this point to this plane. Okay, how can I find this distance? Well, we can do some geometry. So let's call this angle theta, right? Then this will be equal to, if I consider any point P, so I don't know H, but I can find any point P on the plane by just assigning values to its equation. So it will be equal to P0, the length between P0 and P, distance, times cosine of this angle theta. All right. Looking at this picture, all right. Then, now good thing is that I can write this cosine theta easily. So how can I write it easily? So you see, well, this theta is the distance between this vertical perpendicular direction and this vector. So you see this perpendicular direction, well, we already know this perpendicular direction. So this normal vector. So it will be the direction of the normal vector. So this angle theta will be the angle between this N and this vector, let's say P0, P. So it will be, we can write it as follows, n dot P0, P divided by length n times length P0, P. Well, however, there is one little thing. So this theta is supposed to be an acute angle. Okay. So, but when I write it this way, so n is going the other way. So to have an acute angle, we should, its cosine will be absolute value of this one. Okay. All right. Now you see here we will have cancellation. So this P0P and here P0P, they will cancel out. So what will be left is n dot P0P. This is P0P is vector. This is dot product divided by length of n. Okay. Now let's write this one. So P0P, let's give names to these coordinates. So let's say that coordinates of P0 are x0, y0, z0. P is a general point. Its coordinates will be, let's say, x, y, z as before. And the normal vector, again, as before, let's take it as
Hocam sesiniz gitti bizde.
Okay, so now I'm going to write this, this product. So you see, P0P is P minus P0, so it will be x minus x0, y minus y0, z minus z0. Dot product A, it will be the following. So A times x minus x0 plus, let me write it here. So A times x minus x0 plus B times y minus y0 plus C times z minus z0 over length of n, which will be a squared plus b squared plus c squared. Okay. Now let's write this product, distribute. Okay. Equals. So yeah. Now I'm going to collect ax plus by plus cz, and then minus ax0 minus by minus ax0 plus by0 plus c0 divided by square root of a squared plus b squared plus c squared. Okay. Well, in the equation of the plane, so the equation of the plane is, you know, like that, ax plus by plus cz plus d equals 0. It is like that. So I do not have d here, but I can put d. So I will include d here and another one in here. There is this minus anyway, so nothing changes. But this way, doing it this way, I also forgot this absolute value. So there is this absolute value, which I did not put here. So everything is in absolute value. There is the absolute value in here. Well, now after this trick, it is that, so this X, Y, Z, you see, is a point on the plane. So it must satisfy the equation. So you see, this part equals 0 because P is on the plane. So what is left is this part. So AX0 plus BY0 plus C0. What is X0, Y0, Z0? They are the coordinates of the point P0 whose distance to the plane we want to know. D divided by square root of A squared plus B squared plus C squared. This would be the distance between the point P0 and P. So we got this neat formula that gives us this distance. So all we need is to put this point P0 into the equation of the plane and then divide it by the length of this normal vector. It doesn't matter which normal vector we use. So you see, interesting thing is that to write this formula, we used a typical point, a point P here. However, you see during this procedure, this point P is eliminated. So it wouldn't matter which point this P was. Anyway, so we will be using this formula. So we should keep this formula in mind. And it's not difficult to keep it because it is so natural. Okay, let's see it now on examples. How to use it. Example. Find the distance. Find the distance between this point P, whose components are 1, 2, 3, and the plane minus x plus 2y minus 5z equals 4. All right, our formula is here. We will be using this formula. Okay. So what is normal vector here? So normal vector is -1 to -5. Anyways, so I'm going to write the distance as I described in this formula. So I'm going to put this point P, whose distance I want to know, into this equation. So yeah, let's put. So what is A? I take this equation and put x0 equals 1, y0 equals 2, minus 5 times z is 3. However, I should include this 4 on the other side. Yeah. So I take this whole terms, whole equation, divided by length of this normal vector, which will be equal to, so you see it will be like, this is 4 minus 4, 0. So we will have 16 divided by 25. The distance is 16 over square root 30. You see, very easy to find. And it is very easy to apply this, this formula. Okay. Let's take one more example. This time, let's find this formula. Stays in our minds. Example. Find the distance between the planes P1, whose equation is like the following. So minus x plus 2y minus 3z equals 5, and the P2, 2x minus 4y plus 6z equals 8. Okay. All right. So let's find the solution. Okay, well, here again we have a strange thing. So what do we mean by distance between two planes, right? Well, here these planes, if we look at the equations, they are not arbitrary planes. So these are parallel planes. Right? So note that P1 and P2 are parallel. So their picture is like that. It continues like that. So these two planes are like that. So we are asking if these are parallel, this distance between these two parallel planes. Yeah. So we are asking this distance. All right. Well, let me tell you. Let's discuss how we know that they are parallel, because their normal vectors are parallel, right? Because they are normal vectors. So let's write normal vectors looking at these equations. Normal vector for the first one is -1, 2, -3. Normal vector for the first one. Normal vector for the second one. 2, -4, 6. Yeah. And we may note that these are multiples of each other, because are multiples of each other. Well, meaning that you see that n2 is equal to 2 times n1. As we see, -2 times. Which means that these two vectors are parallel. And if the normal vectors are parallel, then planes are parallel. If you remember, two planes are parallel if and only if their normal vectors are parallel. And checking if two vectors are parallel is very easy. We just check if they are multiples of each other. Anyways, so how still we should discuss how we find this distance between these two planes. Well, we do not have a formula right now to find these planes, but it should be very easy. So we have a formula that gives the distance between a point and a plane. So to answer this question, I would do the following. So I would take a point P here on the plane P1, and I would compute its distance. Now, distance means vertical, perpendicular distance for us now. Its distance to this plane P2. So this would be same as distance between these two parallel planes. Let me write it here. We were asked to find this distance between P1 and P2, and we observe that they are parallel. Since they are parallel, this would be the same as distance between a point P for any P in P1. So if we take any point P in P1 and compute its distance to the second plane, then it will be the distance. So we find, how do we find a point P? Point P on P1, how? Well, remember, to find a point P1 on this plane, all I need is to find some values satisfying this equation. So for this, we give usually values for two of the variables and find the other value. For example, for convenience, let's put y equals 0, z equals 0. Then what would be x? X equals minus 5. So for example, y equals 0, z equals 0 into the equation. Then we get x equals minus 5. So from the equation we get, and this means that this point P with coordinates minus 5, 0, 0 is on P1. Okay. Let's now compute its distance to the origin, to the second plane. So now I'm computing distance from P to plane P2. And you remember what we do? I'm going to take the equation. Equation is 2x minus 4y plus 6z minus 8. And then I'm going to put this point P into this equation. So I'm going to put x equals minus 5. Let's put x equals minus 5. And I'm going to put y equals 0. And I'm going to put z equals 0 from here. This should be in absolute value divided by the length of the normal vector. It is 2 squared plus minus 4 squared plus 6 squared. Okay, don't forget to take, so when you write the formula, don't forget to take 8 into this side. So you will take it as minus 8. Okay, so I'm going to have minus 2 times minus 5 is minus 8, and I have, minus 10 minus 8, so I'm going to have 18. In absolute value, divided by, 36, and then 36, 4, 40, 56. So the distance from this point to this plane is 18 over square root 56, which should be the distance from this between these planes. All right. So after finding this distance, the distance between a point and plane, similarly, we can ask how to find distance between a point and a line. Let's now discuss this one. So distance from a point to a line in space. We can also consider distance from a point to a line in the plane, xy plane, which we will do next. All right. Okay, so let's first draw a picture as we did previously. And you will see that using vectors will simplify things a lot. So here is the thing. So we are in space and we consider a line L. All right. And again, we have a point outside. And we want to find the distance again. Now we have the same question. So what do I mean by distance from P0 to this line? So we would mean this perpendicular distance, because this is the distance which is minimum among the distances from P0 to a typical point P on the line. Yeah, same thing. So again, let's denote this one by H. Yeah. So this distance from P0 to this line L should be equal to P0 distance from P0 to H. Okay. Well, now how do I find this distance? H. Well, again, we use some geometry here. So to find this P0 to H, this distance, well, again, I may look at this theta. So I don't know H, but I can take some point L on this line, some point P on this line L, which is easy to find. Okay. Now, in this picture, then, what will be this P0H? So, I'm sorry, this time we should not take this one as theta. So, it will be more convenient to take this, this angle theta. So, let's call this angle theta. So, P could be here or P could be on this side. But in any case, you will see that this P0, this theta will be between 0 and pi over 2. So it will always be an acute angle. Now, this P0 distance between P0 and H will be equal to P0P times sine theta. All right. Now, let's write sine theta. So what is sine theta? Well, for this, I'm going to use, so you see that why is the reason that I consider this angle but not this angle? So I could have written this P0H as, if I could took theta here, then it would be P0P times cosine theta, which is also fine. However, well, the reason that I'm calling this theta, not this one is theta, is that, well, to use this angle theta, I need to find this cosine or sine of this angle theta. I'm going to use this direction vector. So direction vector, so you know, to write equations for lines, we use direction vector. Direction vector is parallel to this line L, right? So you see this angle theta will be the following. So note, let me write here. That's why I'm calling this angle theta. So note that the angle between this direction vector, so P0P P0P is the same. And the U direction vector is, so either theta, as you see in this picture, or I could have U in the other direction as well, right? Because its direction vector is just parallel. It could have been on this direction as well. So then it would be pi minus theta. Anyways, in any case, so now sine theta, what would be sine theta? So sine theta would be, well, absolute value of this P0P. Actually, I could have, anyways, so sine theta will be, so remember, when you hear the term sine theta, you could remember that it is related to the cross product. So sine theta is equal to cross product of P0P and U, so these two vectors, divided by P0P times length U. So we had such a formula, if you remember. So this sine theta will be positive, and it will be length of this cross product. So we had this formula for this cross product, which is very, very important. Okay, you see, if I consider sine theta, I could write this formula. I could find sine of theta because of this cross product formula. So if I consider this theta as I did with the planes theta, then I would have written it using cosine theta. And to find the cosine theta, yeah, I need to use this direction, the dot product formula. But this direction would be perpendicular to normal, perpendicular to the line, which I don't know initially. So for the line, I already know a parallel vector. So it would not be useful, as we did in the planes, to call this angle theta and proceed to find the formula. It worked for the plane because for the plane we use normal vector, which is perpendicular to the plane. Here we use this vector, which is parallel to the line. All right, that's why we should proceed calling this angle theta and writing this distance as depending on sine theta, then compute sine theta as the length of the cross product divided by these lengths. Anyways, so let's now proceed. So this formula becomes what? So in this picture, after this, so let me write again. We want to find distance between P0 and L. And again, we observed that this distance would be equal to distance between P0 and H. And then we observed that this we could write it as P0P times sine of theta. And then we got that this sine theta is given by this formula. So let's write P0P. So for sine theta, I'm going to write P0L cross U length divided by P0P times length U. Okay, well, remarkably, so you see that these two things, P0P, length cancels out. And what is left is that, so P0L distance will be equal to, pardon, this should have been P0P. This is P. Distance between P0P cross U, length of this divided by U. Okay, so this is our formula. Well, the thing is, in this formula, it uses this point P. P is on this line, but it doesn't matter. whatever point we use, it will give the same value. So for any P in the line L, it doesn't matter. But we did not have such a thing for when we compute the length of the distance between a point and a plane. Okay, again, let's take an example. Let me write there. Find the distance example. Find the distance between the plane, between the point P0, 1, 2, 3, and the line, whose equation is as follows, L. So x equals -1 plus t, y equals 3 minus 5t, and z equals -4. Okay. Well, our formula is here. So we will use this formula. And to use this formula, you see we need two things. We need u, direction vector, and we need p. What is p? P is a point, any point, on the plane, on the line. So let's first find these things. Okay. So let's write u first. What is u? Remember, these are the coordinates of this. We find it just looking at the numbers in front of this parameter. So what is in x, what is the coefficient of t? It is 1 times t. In y, what is the coefficient of t? It is -5. Okay, what is in z, what is the number in front of t? It must be 0, because t doesn't show. Okay, so this is the direction vector. And, okay, I need now p, point on the line. And to find it, you know what we do. We put to t some value for t. For example, I put t equals 0. If I put t equals 0, what do I get? I get x as -1, y as 3, z is as -4. So this should be a point on the line. On L. Okay. Okay. Now I can write in my formula. Well, to apply my formula, I need a cross product. So let's compute. P0P cross U I need. Let's compute it. So, well, you know, P0P is P minus P0, right? So it will be like what? So P minus P0 cross. All right, let's write P minus P0. So -1 will be -2. And then 3 minus 2 is 1. And 0 minus 3 is -3. Cross product. U is 1, -5, 0. All right. Well, if you compute this cross product, you know how we compute this cross product. So we put -2, 1, -3, 1, -5, 0. And then you find its length. So
Hocam -4, -3, -7 olacak.
where? Huh.
Orası.
Okay. Well, I leave it to you as exercise to find it. Anyways, so this formula, let me write. This formula will be P0P cross U, length of this divided by length of U. So the length of this will be, I guess, 33, this one, divided by square root of the length of U is 1 plus -5 squared. So 3. Okay. So this is this should be the answer to this question. Okay. Let's take one more example. This time, let's find distance between a line and a plane. Example. Find the distance between the plane P, which is equal to x minus 4y minus 2z minus 1 equals 0, and the line L, which is equal to parametric equations I'm going to write. So x is equal to 2t minus 1, t plus 2, and minus t plus 1. All right. Okay, so again, so when we consider distance between a plane and a line, we should first think a bit, right? So first of all, how can we talk about distance between a plane and a line? So if we have such a picture, right? If P is here like that and L is like that, so what is the distance between this line and plane? It should be 0 because they intersect. If the distance is to be the shortest distance between points in one of them and the points in the other one, then the shortest distance would be 0. Okay. But this is not the picture for this one. So I may note that you see that let's look at the direction vector and normal vector. So direction vector here is 2, 1, minus 1. What is the normal vector for the first one? Normal vector is 1, minus 4, minus 2. Then you may notice that when you take dot product of these two vectors, u and n, it is 0. So this shows that these are parallel. So note L and P are parallel. So the picture is like that. P is like that, L is like that, and this is because, again, n dot u is 0. Just like we had at the beginning of this lecture. Okay. All right. So we can talk about the distance between P and L. So let's write it this way. Distance between L and P. Well, Again, here we can do the one of two things. So either we can take a point on the line and compute its distance to the plane, or we could take a point in the plane and compute its distance to L. So both would give us the same thing. All right, so which one should we do? Okay, so we can either use we can either take a point in here and use distance formula from a point to the plane, or we can take a point here and use distance formula from point here to this line L. Well, I would choose the first one. So because you remember, you may remember that distance formula from a point to a plane is simpler. In the other one, we need to use this cross product. We need to compute cross product. So I would compute this as follows. So L to P will be same as P0P, where P0 is in L. So let's find a point P0. So I suggest to find a point P0 on L and compute its distance to the plane, which is easier. Okay, so how can I find a point P0? Again, as before, so I would give some value to T, then find X, Y, Z. So, and the most practical way of doing this would be put T equals 0. So, T equals 0. Then I'm going to get -1 to 1, P0 minus 1 to 1 is on L. On L. All right, so I'm going to compute distance from P0 to the plane. Now I like this formula, so I'm going to put this number into this formula. So let's put. For X, I'm going to write -1, minus 4 times. For Y, I'm going to write 2, minus 2 times. For Z, I'm going to write 1, and then -1. So this is the complete equation of this plane. And then I divide it by, if you remember, length of the normal vector. So normal vector is 1 minus 4 minus 2 squared. Yeah, if you compute this product, we will get 12 over square root of 21. Okay, so this is the example for finding distance between a plane and a parallel line. All come to this formula. Formula from a point to a line. Okay, well, these are how we find distances from a point to a plane and line. Well, let's now talk about how we find the distances between points and lines in the plane. So these formulas we used for in space, but we can also use them, in fact, in the plane. Let's now see how this happens. So this would be section 3.5. Now we go back to plane. And we want to find distance formula. Distance between a point and a line. And a line in the plane. All right, so here is the picture. we have line in the plane, xy plane. X, y. And we want to find its distance from a point, I don't know, let's say P0 here. There is some point P0 here. However, well, what will be coordinates? We have two coordinates, x0, y0. And there is this distance, this one. And we want to find this distance. This should be perpendicular distance, right? And let's also write the equation. So it will be, what will be the equation of this line like? Ax plus by plus c equals 0. Well, so you see that this type of equations in space give us planes. But in the plane, this type of equations give us lines. So this type of equations are called normal equations. Normal equations. But remember, we also have vector equations. So we used vector equations mainly for lines in space, but there are vector equations for this one as well. So I can talk about it more later. Anyways, so the distance between this point P0 and L will be the same formula we get for the distance from a point to a plane in space. So what I'm saying is the following. Remember, we got the formula just by taking this one and length of the normal vector. All right, now, what is this vector? This will be a normal vector. So now I leave it to you as exercise to see that. So this is ax plus by plus c. So if you consider the vector and AB, just like we did for planes in space, this will be perpendicular to this line L. All right. So N, AB, this is normal vector for L. Normal vector for L. In other words, perpendicular. In other words, perpendicular. Okay, so I want you to show this one, prove this one. Exercise. Prove this one. So really see that in the plane, if you take these numbers in front of x and y, then the resulting vector n will be perpendicular to this line L. Okay, this is exercise 1. Exercise 2. Find a direction vector for L. So I may also ask, find a direction vector. Vector U for L. So I want you to find a vector which is parallel to this line L. Okay. If where L is the line with this equation in the plane. Okay, so these are I strongly suggest you to find these ones and also consider some examples. For example, y equals x plus y plus x equals 1. So do it also on concrete examples yourselves. Anyways, so let's take examples for distance in the plane. For example, again, find the distance between the point P0, 1 minus 2, and 3x minus 4y plus 5 equals 0. in the line, in the plane. We understand that we are in the plane because the point P0 has 2 coordinates, right? If it had 3 coordinates, then we would understand that we were, the question is in the space. Anyways. All right. So let's find, well, very easy. So we will apply our formula. So I'm going to put this point into this equation. 3 times 1 minus 4 times minus 2 plus 5. Absolute value divided by 3 squared plus minus 4 squared plus, that's it. So this would be 16 over 5. Okay, so let's draw a picture. So let's sketch this line, right? So where is this line? So this to sketch this, I find the intercept. So I give x equals 0, then I get y as 5 over 4. And I put y equals 0, then I get x as minus 5 over 3. Minus 5 over 3. So this is my line. And that is the point 1 minus 2. P0 is here, and what I have found is this distance. So I have found this vertical distance. All right, so let's call this one H. So then I can possibly also ask you, find exercise. So remember that, so we have P0, distance between P0 and L is equal to P0 times H. H is where this, we have this right angle. So I'm asking now, find this H. We only know that this distance is 16 over 5, but we can also ask to find this point H. What is it? And this is also a very good exercise. So I leave it to you to work yourselves. All right. Yeah, maybe I should also ask you the following. So another exercise. This equation, 3x minus 4y plus 5, let's consider it in space, right? So let's sketch the graph of this equation, 3x minus 4y plus 5, plus 5 equals 0. In space. So this equation, if we consider it in xy plane, it describes a line. However, if we consider it in space, so there is another coordinate z, then we know that this will describe a plane. So we should sketch this graph of this plane. So this is plane. Well, maybe I should sketch here, just to make sure that we understand the difference. So the difference, so equation is the same, but when we consider where it lives, then it will be different a bit. So 3x minus 4y plus 5. Now I consider it in space. So I have x, y, z now coordinates. Okay, and then I'm going to sketch. So this will be a plane. It is not easy to sketch a plane as we do for the line. So as I said, what we usually do is we look at the, first consider the intersection of this plane with the coordinate planes. So let's first sketch the intersection with the xy plane. So the intersection with the xy plane is intersection of this with z equals 0, but there is no z, so it will be in the xy plane, it will be, the intersection will be this line that we sketched. So it will be from y equals 5/4 to x equals, yeah, unfortunately this will not look so good. Anyways, yeah, this is the line, this line, 3x minus 4y plus 5z. And then, yeah, unfortunately it will not look. So it will be parallel to this z-axis. So it will be like the following. So the correct picture will be like that. So it will be parallel to z-axis. So this will be the plane, but this plane will lie above this line in the xy plane. It will proceed in all directions in a way parallel to z-axis. So z-axis will be parallel to this line. Yeah, you can think about this one. All right, let me take one more example. So find the distance. This time I'm going to give the line in vector equation. So find the distance. So the intersection of this plane with the xy, x coordinate plane will be this line. This will be the relation. All right, find the distance between the point P0, 1, minus 1, and the line L. I will give parametric equations now. L. Yeah, vector equation. It gives like that. P 20 plus T times 4, 3. So this is the vector equation. All right. So how can we find now this distance? Well, so now to find this distance, we use a formula. We use our formula, and our formula uses normal equation. Formula uses xy, right? So first, I find this normal equation for L. So find normal equation. So by this, we mean a equation of this form for L. All right, so how can we find this one, right? Starting from vector equation. Okay, so let's start. So let's write first parametric equations for this one, right? So let's write parametric equations. So you see that P, this vector P. So how do I write parametric equations? I'm calling components of vector P as xy, right? Then this is on the line, so it should be like that for some t, right? Then, well, so what should be x, what should be y? So I take the sum of these two things on the right-hand side. So you see that x will be equal to 2 plus 4t y will be equal to 3t. Yeah. So this is my vector equation, the parametric equation. Okay, now this is parametric equation. Parametric. So there is no z because we are in the plane now. In space, there is also another one for z. In the plane, there are two xy. Fine. Now, how do I pass to this xy equation? So there is x, there is y, but there is also t. So I need to eliminate t, right? Now eliminate t. To get this equation, normal equation. So let's eliminate t. So you see that what is t equal to from the first equation? So it is equal to x minus 2 over 4. From the second equation, it is equal to y over 3. This is equal to t. Now, okay. So you see, I got these equations. This is an equation, and there is no t in it, right? So I have eliminated t, but this must be also familiar to us, right? So what is this? So this was what we call symmetric equation. Symmetric equation. Anyways, now from this symmetric equation, so let's write, if this is equal to this one, so 3 times x minus 2 must be equal to 4 times y, right? So I'm going to have 3x minus 4y minus 6 equals 0. So I got my normal equation now. Normal equation. So let's draw a picture and see how these things look like. Okay, let me sketch this line. 3x minus 4y minus 6. Let's sketch it. So let's give x equals 0. Then y will be equal to minus 6 over 4. So this will be minus 6 over 4. And when I put y equals 0, x will be equal to 2. So this is our line. All right. Well, where is my normal vector? 3x minus 4y. So 3 units to the right, 4 units below, right? So the vector 3 minus 4. If you like, let's sketch it here. So this is 3. This is 4, minus 4, let's say. So where is the vector 3 minus 4? I can sketch. So 3 minus 4 will be somewhere here. Yeah. So this vector, this is the vector now n. 3 minus 4. Okay. So this vector, I draw it sketching from the origin, but doesn't matter. So I could have sketched it anywhere. Anyways, so this is my line. And now I'm considering the point. What point? 1 minus 1. So when x is 1, y is minus 1. So this point, and I'm asking the distance to this line. So my line is 3x minus 4y minus 6 equals 0. All right, so let's apply our formula. So I'm going to put to this point my question, 1 minus 1. So I'm going to put x equals 1 and y equals minus 1 into my equation, minus 6, in absolute value, divided by length of my normal vector, which will be 3 squared plus 4 squared. So this will be 5. And then I'm going to have 3 plus 4, 7, minus 6, 1. So this is the distance. It will be 1/5. It should be small because you see in this picture that this point should be very close to this line, 1/5. Okay, so this is how we find distance between a point in the line, point in the plane and the line. So the crucial thing is that you see these formulas we easily got using vectors. Right? So in short, vectors are very useful, and we should be able to use these vectors very effectively.